We're talking about electromagnetic induction. I was saying this is a process by which electric current is produced. What produces is the magnet, and how is that current produced is when these field lines we're talking about are cut by the wire. Yeah, that's a simple way I can give it to you. This is the process by which electricity is produced. Now, this electricity is produced. This is as a result of these magnetic field lines we're talking about being cut by the wire. Although in most cases, the wires they use are solenoids. So, are in a solenoid rather. So, that's basically what it is. So, we'll be looking at how we can produce electricity. Now, the production of electricity, the rough diagrammatic representation they use is when you have two magnets. We have this magnet here, this magnet here. We also have another magnet there. These two magnets, two strong magnets are brought together with a bit of space left in between. So that is what we'll be looking at now. Now, these magnets that are brought close to each other, we need to have their polarities known. Which one is the north pole, which magnet, and which one is the south pole magnet. So we take the situation that this is the south pole, this is the north pole, this is the south pole, and this is the north pole. Now, from the magnetic field lines directions that we just from talking about, we understand by now that these magnetic field lines move from the north to the south. Do you remember?
Yes.
This is what we are from talking about. That was the whole essence of learning that. It's because see, we try and understand the movement of these field lines. Now, them moving from the north to the south. Remember, we are saying electromagnetic induction is a process by which electricity is produced. Now, the way that electricity is produced is when these magnetic field lines are cut by the wire. Now, how is that done? And when this is produced, how can we tell which one is a positive terminal of the wire and which one is the negative terminal, so that we can tell the direction in which the current is moving? That's the whole idea of us learning this today. So once you have the direction of the magnetic field lines known, then you need to have a wire, because we're trying to learn how electricity can be produced from this simple phenomena. So when you have a wire, this wire, I will have it lined up in this way, okay? Let's say we have a wire, okay, between the way these magnets are, then we have a wire that is standing perpendicular. Then, the moment you get to have this wire coming down, it is going to cut these magnetic field lines. The moment this wire passes between the magnets, you will find that these magnetic field lines will be cut. Now, the moment this wire cuts the magnetic field lines, the induced current will be produced. And when it is produced, it has to flow through the same wire which had the magnetic field lines. I'm going to repeat. What I'm trying to say is these magnetic field lines moving from the north to the south poles of the magnet, and then when you have a wire cutting through them, you will have these magnetic field lines cut by the wire passing through them. And when that happens, you find that the induced current is going to flow through the wire which cuts the magnetic field lines. So if you have a wire in that direction, now remember, we are talking about perpendicularity here. We have, this is a direction of the magnetic field lines, okay? It's the direction of the magnetic field lines, and then this wire is cutting across. Okay, this wire is cutting across. Now, this wire is going to cut across this wire. This wire is going to cut across this magnetic field at a perpendicular. So now there are few things that are important here. There are a few things that are important here. How can you determine now the direction in which current is going to move in this wire, which is cutting magnetic field lines? So there, what we use, not the right hand grip rule, no. Here now what we use is the Fleming right hand rule. The Fleming right hand rule is a rule that we use, or is a rule that governs, or is a rule that helps us to determine the direction in which the induced current, now the current that is produced by electromagnetic induction, the current that is produced by electromagnetic induction is called induced current. Induced current. The current that is produced by the electromagnetic induction is called induced current. Okay. Now, how can you determine the direction in which this induced current moves? So what happens here is we use what we call Fleming's right hand rule. Now, the Fleming's right hand rule here is different from the right hand grip rule, because right hand grip rule, we considered all these fingers to be pointing the direction of current, and then the thumb shows where the North Pole is. But for this one here, we have the thumb. In the thumb here, we just get M. M represents the movement of the wire. We use thumb, which is representing the movement of the movement of the wire, which is cutting the magnetic field lines. And then we have we have the first finger. We have the first finger. In the first finger here, we use F. The finger should represent the flow of magnetic field lines, the direction in which the magnetic field lines are moving. Then the other one is the second finger. In the second finger, we use the C, which represents current. So in the determination of the current, in the direction of the induced current, we use 3 only. A thumb representing the movement of the wire. Is it moving from below going up as it cuts the magnetic field lines? Or is it moving from the top coming down as it cuts the magnetic field lines? That direction of the wire will be represented by the thumb. Then the first finger is representing, we have to point the direction in which the magnetic field lines are going. Then the thumb, the first finger, will definitely determine the direction in which the induced current will go. So here we go. We have this magnetic field, lines that are lined up in that way. We have these magnetic field lines that are lined up in that way. Then we have this wire which is going in an upward way. We have this wire which is going in an upward way and cuts the magnetic field lines. So what are we going to do? I am going to do this. Okay, I am going to do this, whereby I will have the first finger. I will have the thumb, by the way, pointing the direction in which the wire is going. So I will have my, but you have to make sure that these three fingers must right angle. Here must make 90 degrees. Here 90 degrees, as well as this must stand 90 degrees to the plane. Okay, so once that happens, you will find that we are going to position our thumb in that, or our hand in that way. Okay, let me join Mari. Okay, we are going to have it in that way. Let me stand and demonstrate. So we are going to no, this one is different. But yeah, it's this. We are going to demonstrate that the thumb is pointing the direction where the wire is going. Then the first finger shows the direction of current, and then this first finger must. So if you have a wire here which is going in an upward direction like that, okay, which is going in an upward direction like that, you will find that the movement of the current will be in that direction. Okay, so if you have which is moving upward, you find that the current will be flowing in a downward direction. So that is how we can determine the right hand rule. But now what happens is that the moment now going to this wire goes up, the current flows towards in that direction. The moment you're going to bring this wire down, the current will flow in the different directions. That's what happens. When the wire cuts the magnetic field lines in an upward way, the current will flow in a particular direction. You can determine by framing the right hand rule. And then when the moment the wire cutting the solenoid, wire cutting the magnetic field lines in a downward way, the current will flow in the different directions. So that is how the electricity is produced. That current is this current is produced by the method we call electromagnetic induction. Are you okay?
Yes.
Okay. So now let us see how we can have now the large product, or how can we demonstrate this now in a scientific way. I think that's where we're going to end. But to still be sticking to this, how can you now demonstrate this in a scientific way? Remember, I said that the production of current is done not by a single wire, is not done by a single wire, but by a number of wires that are wrapped up in what we call a solenoid. How can you now demonstrate the induced current being produced by electromagnetic induction by the use of the solenoid? So what to do here, we need to have now the solenoid. We are also trying to demonstrate that the moment you change the direction of the you will have the direction of current also changing. Now, this is another way in which now you can show. Okay. Now here, what you need to have is a pointer, which will be pointing the direction of current. And this pointer, in most cases, they use a galvanometer. It's an instrument which is very sensitive in terms of deflection to show the direction where the current flows. So the instrument that we're not measuring the quantity, no, we are measuring the direction in which the induced current is being produced or in which it is flowing. So now this is a solenoid. Here we have the connecting wires that are connected to the solenoid. This solenoid is pointing in the initial position. It is pointing in that way. It's pointing that way, showing that there is no current produced. So what happens is that we're trying to look at the scenarios. One, when you are inserting the magnet inside of the solenoid. One. Two, when the magnet is stationary inside the solenoid. And then the third situation is when now the solenoid is have the magnet going outside the solenoid. So let us see what happens. Three situations. The first situation is the magnet going inside of the solenoid. The second one, the magnet is stationary inside. Then the third one, we have now the magnet being withdrawn from the solenoid. What happens? Okay. So now, remember we're saying that the particularity in terms of direction is very, very, very vital here. So we're trying to imagine we have our magnet here. Now, if this is a north which is going inside of the solenoid first, what happens? How is the current going to flow? It is different when you switch the polarity of the magnet. The direction will also change because that's what I said. So now, the first scenario now is the moment you put the north pole of the magnet halfway inside of the solenoid. Let's say when you see when we have the north pole of the magnet inside of the solenoid, we are going to see that this pointer will deflect. This pointer will deflect. So instead of it being that way, it is going to deflect in that direction. It is going to deflect in that direction. Now, the moment you have the magnet resting after halfway it goes in, then you slide it inside and it stops moving. The moment the magnet stops moving inside of the solenoid, the pointer will go back to the initial position. Why? Because there is no current produced. And the moment you're going to withdraw now the magnet outside of the solenoid, again the pointer deflecting. What is it that it is trying to tell us? It is telling that the current is only produced when there is movement or when there is continuous cutting of the magnetic field lines. Now you may ask yourself, is the one which is moving this time around is a magnet? How is current being produced? Remember, if you have a magnet inside here, we have the magnetic field lines, a lot of them coming out. So instead of these magnetic field lines coming out, there are already wires that are which will be cutting the magnetic field lines as the magnet slides in or out. Are you seeing that?
Yes.
So now the next time you're going to change, you have the south pole here and you have the north pole here. You find that instead of the galvanometer deflecting that direction, this time around it will deflect in the opposite direction. So now, three things to note. One, they will ask, how can you now increase the size of the induced current being produced? How can you increase the size of the induced current that we can produce? One, you increase the number of solenoids. You increase the number of turns in the solenoids. In here, you need to have a lot of wires in the solenoids. When you have a lot of wires in the solenoids, you are having chances of increasing the size of the current which is being produced. The other one, how we can increase the size of the current is by increasing the speed by which the magnet is going inside of the solenoid. When we increase the speed at which the magnet is going inside of the solenoid, we are increasing the size of the induced current that is produced. Then the third one is to use a stronger magnet. Stronger magnet. Are these there in the notes that I sent you? Okay.
So,
Is this there in the notes that I say? Oh yeah, they are there. So if you have written them, that's better. Yeah. So these are three things that you can do in order to increase the size of the induced current produced. You have to increase the number of turns in the solenoid. You have to increase the speed at which the magnet goes in and out of the solenoid, and also have to use the magnet which is a little bit stronger. So those are the few things that we have to know. Any question? Hello?
no, sir.
Okay, so you have to, I don't know, the test you did not do good. What happened?
Which one, sir?
The one that I gave in biology.
On Thursday?
You didn't do a pretty good job.
I did. Oh,
What happened? He forgot because on the blood disorder, he didn't write much of what
I
was.
forgot.
It means you didn't start because I gave you a few things in biology. I don't know how you could forget. Okay, let's switch now to math. Okay,
Huh?
we switch to math.
Okay.
Just a minute. Thank you. Okay, so we try to switch now to math. Math, it's like a very short presentation that we're going to have because it's just going to link to what we have been looking at so far, except that there is a bit of a new concept that we're going to learn. But to today's presentation,